Hello everyone, my name is Ranjita Rathod and today we will discuss about the probability which is included in the engineering mathematics for the second year students. So firstly we will discuss what is probability. Probability means possibility. It is a branch of mathematics that deals with the occurrences of a random event. Means occurring of a random event it deals. For example, tossing a coin. When we toss a coin, there is a possibility that we can get a head or a tail. Next, rolling a dice. While we play the snake and ladder game, there we can get 1 up to 6. There we can get 1, 2, 3, 4, 5, 6. Any number of between 1 to 6. Next, playing a cards. While playing a cards, there we can get diamond, king, ace, anything. So these are the examples for the probability. So in this today's video we will derive the Bayes theorem. To derive the Bayes theorem we have to know about the definitions, some rules and some Venn diagrams to understand the Bayes theorem. So first one is, what is the exhaustive event? An event consisting of all the various possibilities is called an exhaustive event. Means it consists all the various possibilities, means it can be head or tail. While throwing a dice it can be 1 to any number of up to 6. So like that, so it is an all various possibilities. Next, mutually exclusive events. Two or more events are said to be mutually exclusive if the happening of one event prevent the simultaneous happening of the others. Means happening of one event prevent the simultaneous happening of the others. Next, we will see some important laws on set operations. To understand these laws, first we will see the Venn diagrams for the set operations. So these are the four Venn diagrams to understand laws on set operations. Here is A and here it is a B. A union B means A is also consisting of all the shade parts and B is also consisting of all the shade parts. And second one is A intersection B. Here it is a A and here it is a B and it is a intersecting. So A intersection B. Next is A minus B. A elements of A excluding the elements of B means it is a empty and it is the shaded part. So A minus B means excluding the elements of B. Next here it is shaded all the part and also shaded the B part. So it is the all the elements of A. So now we will discuss the set operations. That is A union B is equal to B union A. Here we use the union. Correspondingly, we have to use the intersection. So A intersection B is equal to B intersection A. This is called as commutative laws. Next, A union of B union C is equal to A union B of union C. Here we use the union. Correspondingly, we have to use the intersection. A intersection of B intersection C is equal to A intersection B of intersection C. This is called as the associative law. Next, A union of B intersection C is equal to A union of B intersection A union of C, while A intersection of B union C is equal to A intersection of B union A intersection of C. This is called as a distributive. This is an important, this law we will use in the Bayes theorem. So it is a distributive law. Next, we use some rules, that is additional rule, multiplication rule. So what is meant by additional rule? P of A union B is equal to P of A plus P of B minus P of A intersection B. This is an additional rule. Next, what is the multiplication rule? P of A intersection B is equal to P of A into P of B. Next, we also use the conditional probability, that is P of A by B is equal to P of A intersection B divided by P of B. Next, P of B divided by A is equal to P of A intersection B divided by P of A. These are the rules and some set operations which will you use to derive the Bayes theorem. So we will derive the Bayes theorem. So first we will see the statement of the Bayes theorem. Let A1, A2 up to An be a set of exhaustive and mutually exclusive events of the sample space S with P of Ai is not equal to 0 for each I if A is any other event associated with Ai with P of A is not equal to 0. Then this is the formula we have to derive. P of A by A is equal to P of A by P of A into P of A by Ai divided by summation of i's to 1 to n P of A by Ai into P of A by Ai. So firstly we have S is equal to A1 union A2 union up to An and A is a subset of S, therefore A is equal to S intersection N. So we know what is S. S is A1 union A2 union up to AN. So A1 union A2 union up to union AN, and here it is the intersection. That's why we are putting the intersection and A as it is. Next, using the distributive law in the RHS we have A is equal to, here we use, so A is equal to A1 intersection A union A2 intersection A union up to AN intersection A. Since AI intersection A for I is equal to 1 to n are mutually exclusive, we have by applying the additional rule of the probability. Just recent we know the additional rule of the probability. By using the additional rule we have to derive. So P of A is equal to P of A1 intersection A plus P of A2 intersection A plus P intersection of AN intersection A. So now applying multiplication rule onto each term in the RHS, we have P of A is equal to P of A1 into P of A by A1 plus second term P of A2 into P of A by A2 plus up to P into AN into P of A by AN. So that is, we already told here I is equal to 1 to n. So P of A is equal to summation of I is equal to 1 to n. P of by simply for writing A1, A2, A3, just we are taking it in the general form, that is AI. So P of AI into P of A by AI. So consider it as equation 1. So next, the conditional probability of AI for any I given A is defined by. So by using the conditional probability, we have to reduce the form. So P of A by AI is equal to P of AI intersection A divided by P of A. That is equal to P of AI into P of A by AI divided by P of A. So now using the equation 1, that is P of A is equal to summation of 1 is to n P of AI into P of A by AI. By using that one, the denominator of the RHS we have. So P of AI is equal to A, that is P of AI into P of A by AI. So this equation 1 we use it as a denominator, that is this, and here it is also derived, that is P of A by AI into P of A by AI divided by P of A by using the conditional probability. So by using the conditional probability and by using the multiplication rule we have derived, that is P of A by A is equal to P of AI into P of A by AI divided by summation of 1 to n P of AI into P of A by AI. This proves the Bayes theorem for conditional probability. Thank you guys.